Hey students, welcome to Learn Digital. I was discussing about network and today I will continue my discussion. I started discussing the data communication and networking. Why do we need that? We need data communication or networking because we want to send information from one place to and any person from point A to B wants to send information, and in this case to send information we need a medium, and we call it transmission medium, and this is the sender and this is the receiver. So in this case we want to send, suppose, hello, and you type hello here and it goes there. How it is possible? To make it possible, we have this is the machine, this is a computer. So this machine is actually having some softwares or some set of rules which is actually making everything possible. When those instructions are being executed in this machine, that machine actually sends information from its memory to through this channel, and this information arrives at this point. When the information arrives at the receiver end, the receiver in turns, there is a software, the same software in a it works in a reverse mode, that it receives information at this point, and it fetches information and it keeps in its memory, and eventually it forms the hello message here in front of the user. Here the user is sending the information hello. So here these softwares we call, or this set of rules we call protocol. Sometimes students they don't get what does it mean, the protocol, and they just go through the book and they just try to like understand in a not in a practical way. So you have to understand everything in a very practical way, and and this is the way you should learn that. Nothing to consider that that this is already developed and we cannot understand the requirement or the necessity of the development, so we cannot go through that journey. So it is very much necessary that when you understand anything, when you want to understand anything, at that point you try to figure out why that thing was developed, what was the requirement at that time, or the requirement behind that development. So in this case, if the internet is required, why? So if you can answer this why, then you can understand the concepts very well. If you just start understand if you just start reading all these things directly, you will lose your interest. So to keep your interest intact, it is very much important that always you find out the reason. So the here we need network because we want to exchange information, and this is necessary. It is not a theoretical thing, it is a practical thing, and that is the requirement of everyone. When there was no network, the information used to travel through human being used to take information from one point to another. When we have technology, when we have phone, we can call, means the verbally we can talk, but through electrical signals, your audio will be carried with the electrical signals. It will travel across the globe and can reach another point. So here we are not talking about the telephone. Now we are talking about internet, where we just want to send information, and information in or we can say digital information from one point to another, means information available in any machine, and we want to send that information to another machine, and this is present day's requirement. So based on that requirement, if we want to send information, so we need a medium, and that medium can be a wire, a group of collection of wires which are connected to this machine, and this machine we call it a guided medium. Or we can have a two machine, and we have suppose wireless medium through, suppose, radio wave. So this is also a network, but the medium is the media is here is wireless through air. So it is called unguided medium, and it is possible with energy uh, wave. So our when we talk, when we are personally talk with another person in a close vicinity, we can talk to another person, and the medium is air. So if you want to talk a person, they are staying at Delhi and you are at Agartala. So at that point you cannot talk that to that person directly, because your audio will not reach there. So at that time you need a carrier, you need a travel transmission medium, and this medium cannot be your audio directly. So it should be electrical signal. So this electrical signal will travel through these wires, and this it will carry your audio, and it will just take to the receiver end. So this is the fundamental of having a wire, we all understand. And it can be wirelessly done, it can be wired or guided or unguided. So in guided, we have some wires, electrical wires, coaxial cables, optical fiber, the latest technology, the optical fiber. We'll discuss about how optical fiber works. So the we are just focusing on the point that if we understand the protocol, how the machine is actually able to send information, and how this information is traveling through the huge like distance through many computers. So now I've mentioned that many computers are there in between. So those computers are actually forwarding your message from your machine to the next machine, from that to this another machine, from that to that. So these are the machines which are actually placed between you and your receiver, or you as a client and the server. So why those machines are required? The single answer is, the only one answer is that it is not possible that you connect a single wire to Google's server. So in this condition, we will be having many computers in between, or we will be having many digital systems in between, which will actually forward your message further and further, until and unless it reaches the destination, the server. So these are called network devices. We call it a router, we call it routers. So it's easy thing, it's a very simple thing, that yes, we need a intermediate device. Again, we need an intermediate device. Those intermediate devices are called routers or network devices. So I have just drawn few routers, 1 2 3 4 5, suppose. So there are many numbers of routers, as much as many as required to just take your message from your machine to the server. And there are it is like that, in between you and the server, the routers are like that, they are placed like that. Many numbers, huge number of routers are there, the whole internet. And there are client machines. So those client machines are actually connected to the routers. Suppose this is the router, your machine is connected, and it is the server, it is the server side router. Suppose router 15 is connected. So here your machine is connected to this router, the server is connected to this router, server machine. So how to make the communication link between these two routers? Once you can make a communication link between these two routers, so your message will be automatically sent to the server, because the server is connected to this machine. So this is called the routing protocol. Routing protocol means to making the path, or to just build the path between these two routers, because there are many routers. So you can make a path like this, you can make a path like this, you can make a path like this, you can make a path suppose like this. And obviously you will say this, yes, I want to make a path like this, because this is the shortest path. So the shortest path will be decided by the router itself, because the logic of finding the path independently, every router is holding that information. This is called the beauty, this is called the distributed the distributed way of maintaining the network, because no central system is maintaining the entire network. In actually the routers are defined, or routers are having the information to maintain the network information, and how to forward the message and where to forward. Because see, if I draw the lines between those routers, there are many line, because one router can have multiple connection, one in connection, and there may be multiple out connection. So here in this case, suppose this router receives your message, and there are 1 2 3 4, which router this router will select. It is already known to the router, because this is called routing protocol or routing algorithm. Routing, and eventually we will understand how these routers actually manage to select the next router. So suppose this router selects this, and this router is having again 4 and 5 6 7, suppose 7 routers are connected. So in this, which router, suppose this router selects this based on the algorithm, and we'll discuss about this. No need to think about this algorithm right now, just you get the overview of this lecture to understand the overview of the network and data communication, where every elements taking place, every devices, every concepts taking place to this data communication happen. So this is actually the next router. Again, this is having 1 2 3, which will be selected, or 4, here is another. So this is selected, and this router is having suppose 3 and 4, 4 and 5, for 5 or 6 connections. And it is the best thing that this router selects this. And once this router is selected, this router knows that yes, I have to send this to this server. So this is very important, that how does this router doing all this calculation, and how does this all these routers know who is the server. So at this point, another thing arrives, which is very important in network communication. Without this, it is not possible to make such global network of networks, to maintain and to know senders, receivers, clients, servers. Because how do we identify uniquely that yes, this hello has to reach from this point to this, not this point to this. It is not the receiver destination, so it is called IP. It is called IP, address or a number. So IP is internet networking protocol, address, internet protocol or internet networking protocol address. So what is this? It is actually a number, four integers together, like this, separated by dots. So it's together a number, 32-bit number. Suppose 105.45.50.101. Randomly I'm just selecting. Oh, this is the number given to this, unique to this entire network, and this is the number 105.60.5.3. Suppose this number is given to this, and every devices are having their own unique number, which is called IP. Because see here, this every device, if they do not have unique IP address, then they cannot act as the node in the general global network. So in this case, every machine has their unique number associated with it. This is called global IP address or IP address. And so this IP address is actually the IP address of this machine, and this is the IP address of this machine. So when this sender is sending hello, actually this information is actually labeled with this IP address, or IP address is attached with this. So when this routers actually receives this hello message, and or the part of the hello message, because this hello message is actually into, broken into pieces, equal pieces, or say, same size pieces. We call it packet, made into packets, and these packets are actually arriving to the next, and go further. So when these packets of this hello arrives here, so this router actually knows what is the destination number. So this is the destination number written on this. Suppose this is 105.60.3. This is written on this packet, and it will be received by this router, and this router knows where to forward, because based on the algorithm, based on the routing protocol, this will be forwarded here. So this way, every router actually sees this IP address, and based on this IP address, they forward the message. So based on the IP address, the routing protocol works. So this is very interesting. It is like when we send a letter through post office. So at that time that the full address is written on the envelope, and the post offices are actually the routers. The intermediate post offices all over India, all over nation, all over world are the routers. So they know how to forward, because the address is written, or the pin number. We call 79900, 7990001 is the Agartala's pin number. So it will reach to Delhi, it will reach to Kolkata. So based on the pin number, they forward the envelope. So here it is in our digital network, computer network, we forward the router forwards this packet based on the IP address. So routing protocol is working on the IP addresses of the packets. So they will deliver the packets, and this is the path instantly built by these routers together, and they are just forwarding the messages. And there is a very interesting thing, that this hello message, suppose these are the packets, 10 packets or 100 packets. When hello message you want to send, it is broken into 100 packets. That 100 packets will not follow the same path. Suppose 10 packets are following this path, or 5 packets are following this path, and other 20 packets are following this path. So based on the dynamics of the network, the routers will select its best possible next router or next destination. This way the messages will be dynamically forwarded, or the routing will be dynamically done, and message will be delivered. Because see, there is no fixed path between two machines in this internet, that this fixed path will be always followed. Because see, if there is a problem with this router, sometime this router is not suppose working, suppose it is not working, so in this case, these 4 messages will be going through this path. This will bypass this, or this will go through this and this. So this is called the beauty of this total network, where some part of the network, if it is damaged, then the rest of the network will not be collapsed, or the routing protocol will hold everything intact, and it will deliver your content. That's why the reliability comes, that it will secure your communication, or it will ensure, not secure, ensure your communication from source to destination anyway. So this is called the routing, where the routing is done very beautifully. And let us continue our discussion with other facts. Let me show you a few pictures, if we can get anything. So this is the protocol, that there are many machines in the network. So protocol is a common thing which will be followed by all the machines, because when you are sending something, every machine in this network must know how to send, how to receive, how to decode, how to encode. Otherwise there will be no communication. The message will reach to the destination. If the reassembly, because you cut the message into pieces, and you are sending through as packets. So when the packets arrive, the destination network network or the destination machine. So that machine, the packets need to be rearranged, and the receiver must get the sender's message uh, intact. Whatever the sender sends, the receiver must get intact. So this is called the same protocol is followed all over the network and by all the machines. So we know that in our case, this is the name TCP/IP. The World Wide Web, or this internet, is actually following this protocol. Means in internet, any machine on in this network are actually in this machine in this all these machines, the TCP/IP is followed. So practically we see, if we consider that, yes, your machine, suppose this is your machine and this is the Google's machine, so your machine is again following the TCP/IP protocol, because your machine knows how to send information, making packets, labeling your packets with the IP address, labeling your packets with other informations. So it will be done by your machine as a client, and it will be again forwarded to this machine again follows the TCP/IP protocol, and how to do all these things, and how to forward the message. Suppose, see, when it forwards, your machine forwards to this machine is having connection with this and this, so where to forward. So it will be the best thing to for the best selection. So how this machine selecting this machine, it is written in the TCP/IP protocol. This is called routing protocol, as I said. So this way, when it reaches to the destination, and the destination receives all the packets, and I said that your machine will be delivered, your messages will be delivered into packets. And suppose your message is having, it is cut into 100 packets, so 100 packets will travel through different paths, and the different paths are managed by this entire network independently by those routers, because when any packet reaches to any router, that router knows where to forward it, so it will not match with the previously done routing, previously received packet. One router is receiving one packet 1, and it is forwarding to this, and next time when it is receiving packet 20, and it is forwarding to this. So this may happen. This is the dynamic nature of this network. And some packets will follow this path, some packet will follow this path, and every packet reaches here. If there is a missing packet, suppose the sender sends 100 packets, and this receiver receives 90 packets. So in that case, 10 packets will be again sent by the intermediate routers, because this message will again forwarded broadcasted from this receiver, that yes, I did not receive the total number of packets to be sent. So the network will again send those messages to the receiver, and when the receiver receives all the packets, and that receiver will rearrange in a very sequential manner, means because every packet will be having a sequence number, so it will match all the sequence number, and it will again rebuild the hello message in its original form, and it will display to the will be displayed to the receiver, like the client sitting in front of that machine. So this is the concept of uh, the total TCP/IP. Every machine is following the TCP/IP. So this is the diagram, that this is your machine and this is your friend's machine. So you are connected to this network with a local service provider. Suppose in this case Jio, BSNL, Vodafone, Airtel, these are the suppose service provider. They are actually again the part of the total entire network, and this network is not having any centralized form. Each part is actually maintaining the entire concept of TCP/IP, or the networking or the data communication, and they are equipped with this TCP/IP. So you are connected with your uh, network this through this network service provider, internet service provider. And this internet service provider is a group of so like collection of machines, again a network, a small network, where everything is managed, and this will forward your message this way it will be reaching to the destination, and destination it will be again reassembled, and your friend will be able to see your message. So these are done in very with a great speed. So many things are actually taking place in a fraction of second. And and this is the concept of internet, that the independent routers or the clients, everyone is following TCP/IP, and no one is actually controlling the entire network. There is no group or common or the total collection of PCs or servers are controlling the entire network. There is no such architecture. The architecture is like that. It is in a very distributed manner, that this machine or the router knows how to do forwarding with the best possible uh, options. That this is its option. It is connected to 4 5 machines who had to forward, and from that fire to forward. So independently, any part of the network is damaged, then this part will not be active. This part will not be active, but the rest of the network will be working. So this is called reliability. So we discussed this. So this is another diagram. I already discussed that this is your machine, this is a server. So in between we have many machines, routers. So here this router receiving your messages or packets, and it will forward to this or to this or to this. So it is based on its algorithm, or based on your its algorithm. So this will be forwarded further, and it will reach to the destination. And the destination server, it will like rearrange all these things. It will ensure that the message is intact, and it will act, and it will again reply, and the reply will come through all this total network, and it will reach to the again destination, in this case the client.